Okay, I'm rapidly running out of time on campus here. I am on page 720. This name sounds a lot worse than it is. This is easier than the previous section, I think. Um, it's much easier, I think, to multiply and divide than to add and subtract, because adding and subtracting, you have to worry about the lowest common denominator. Um, but, well, whoops, I guess I just lied. On the first one, you do have to find the lowest common denominator. I was looking at the multiplication ones and division. Anyhow, so let's just go through this. If you have something, I'm just going to get through the example. If I have 2 plus 4 all over x minus 1, this is really just kind of a continuation of what we did last time, where you can't add those because they don't have a common denominator. So the common denominator is going to be x minus 1, which means that you need to do this. All right, I just multiplied that 2 by the common denominator. You remember when you do common denominator, you have to multiply in the numerator and denominator. All right, so, and then I have plus 4. I don't need those parentheses, but whatever. It does not matter. X minus 1. So this one was already fine. This one, in order to add them, needed the same denominator. Now I can add them up. And this is going to, I'll distribute that 2, so that's going to be 2x minus 2, 2x minus 2, 2x minus 2, plus 4, all over the common denominator of x minus 1. And so 2x minus 2 plus 4 minus 2 plus 4 is what? 2? All over x minus 1. Oh, that's plus 2. Excuse me. 2 minus 2 plus is plus 2. Okay. And there's really not anything I can do with that. I could factor a 2 out there, but it's not going to help me. So that one's actually just done. That's simplifying a mixed expression. All right, simplifying a mixed expression, because that needs a common denominator to be able to simplify it. That's that one. The complex fractions are just stuff that we've been doing earlier. So a complex fraction, and the complex fraction would be something, if we had something like 2/3 divided by 5/8. You know that you can rewrite that as 2/3 times 8/5. Because when you divide by a fraction, take the fraction in the denominator here and flip it over and multiply. Okay? Oopsies, that's 2/3. 2/3. Take what's in the denominator and flip over that fraction. Okay, so that's going to be 2 times 8 is what, 16? So as you know, 2 times 8 all over 3 times 5, which is 16 all over 15. If you have let's see, 8t squared all over v divided by 4t all over v cubed. So we'll flip over the fraction in the denominator and multiply. So that's going to be 8t squared all over v times v cubed all over 4t, 8t squared v cubed all over 4t times v. Find your greatest common factors here. So 8 is 2 times 4. T squared is t times t. V cubed is v times v squared. I just broke this thing into its the common factors, and I'm looking at the denominator to guide me, all right? Because this has a 4, so this is 2 times 4. That's that 4. This has a t, so that's why I did t times t. That's that t. And here's this v. That's why I did v times v squared for v cubed, because there's a v here. Now, divide. Whatever you can divide. 4 divided by 4. T divided by t. V divided by v. And I get whatever's left over, which is 2t v squared. And that's the answer. And lastly, let's see if I get 2 more examples here. And I apologize for rushing. I've got to be off campus here in like 15 minutes. 2 all over y plus 3 divided by 5 over y squared minus 9. So that's going to be 2 over y plus 3 times, flip over this, so that's y squared minus 9 all over 5. This factors, so that's going to be 2 times, this is a difference of 2 perfect squares, so that's y plus 3, y minus 3, because it's the difference between 2 perfect squares, y squared minus 9, all over this, which is going to be 5 times y, 5 times y plus 3. Now factor what's common in the numerator and denominator. I mean cancel y plus 3 and y plus 3. So that's 2y minus 3 over 5. And you can't do anything more with that. And then the last one is just kind of ugly. Sorry if I insulted it. But we have n squared plus 7n minus 18 divided by n squared minus 2n plus 1, all divided by n squared minus 81, which is a difference between perfect squares, all over n minus 1. So let's rewrite these things. N squared plus 7n minus 18 all over n squared minus 2n plus 1 times, flip that over, n minus 1 all over n squared minus 81. Let's see what we can come up with here. Okay, so let me see, 18 is 3 times 6, it's 2 times 9, so negative, since it's a positive, so positive 9 and negative 2. So that's going to be, and I'm multiplying, so n minus 2, n plus 9 are the factors of this, all right? Negative 2 times plus 9 is negative 18, negative 2 plus 9 is plus 7, times n minus 1, all divided by, this is, the factors of this are negative 1 and negative 1, because negative 1 times negative 1 is plus 1, negative 1 plus negative 1 is negative 2. So this is going to be n minus 1, n minus 1. Those are the factors of this term. Times, this is the difference, n squared minus 81 is n plus 9, n minus 9. It's the difference between 2 perfect squares. Now look at anything that is the same in the numerator and the denominator. You have n minus 1 in the numerator and in the denominator. And I have n plus 9 in the numerator and n plus 9 in the denominator. And then anything that's left is, well, left. So there's n minus 2 divided by n minus 1 times n minus 9, and you cannot do anything with that. Okay? So that ends that section.